For numbers 3 through 7 on the Chapter 6C homework, we are using the 68, 95, 99.7 rule of standard distributions, standard normal distributions. And so I've made this picture here to kind of illustrate the rule in a little bit more detail. So first thing, the 68%. 68% of the data is within one standard deviation of the mean. That means if you go to a z-score of +1 and a z-score of -1, the area in between is 68% of the data. 95%. If you go from a z-score of -2 to 2, so this line to this line, that's 95% of the data. So 95% of the data is 2 standard deviations from the mean, or within 2 standard deviations from the mean. And then lastly, I didn't write it on here, but this would be a z-score of -3. This would be a z-score of +3. And 99.7% of the data would be in that range of values. So that's what the 68, 95, 99.7 rule states. What that means about the outside areas is that if 68% is in here, then you have 16% below a z-score of -1 and 16% above, because 16 plus 16 is 32, plus 68 gives you 100. So you can use this rule not just to determine what percent is in between, but also how much is below a z-score of -1, 16%. How much is above a z-score of +1? It's also 16%. How much is below a z-score of 1? Well, a z-score of 1 is here, so you get this 68% plus another 16%. So 78, 84% of the data is below a z-score of 1. So you can use this rule in a number of different ways to determine what percent of the data is below a certain z-score or above a certain z-score or in between two z-scores. And all you need to know is this rule, and you can do that for any value that ends up with a z-score of -1 plus 1, -2 plus 2, -3 plus 3. All right, so let's go to the problems. So for problem 6.3, all right, so this is problem 3 here. You have a mean of 85, standard deviation of 20, and there's 3 parts. We're looking at the rates less than 125, greater than 105, and in between 45 and 85. So 125, 105, 45, and 85. In order to use the rule, we need to know the z-scores for all 4 of those values. So that's what I've done here. So this is the z-score for 125. You subtract the mean, divide by the standard deviation, and you get 2. For 105, you subtract the mean, divide by 20, you get 1. For 85, 0. For 45, -2. So we have the z-scores for all of those different values. Now let's go back to the question. We want the relative frequency of rates less than 125. So less than 125. So z-score of 2, we're here. What is less than that? What percentage less than 2? Well, we have 95% plus 2.5% for a total of 97.5%. So 97.5% of the data would be below a value of 125. For this next one, 105, we have greater than 105. So now we're going greater than 105. Well, back to my graph. 105 corresponds to a z-score of 1. The percentage is 16. 16% is above a 1. Okay, and then for the last one, it was in between these two values. What percent is between 45 and 85, which correspond to 0 and -2. So -2 is right here. 0 would be the midline. So this full distance is 95%, so it's half of that. So it's from 0 over to -2. So that's half of 95%, so 47.5%. Now, one other thing on this, they are saying relative frequency instead of percentage. Relative frequency, it just means give the proportion rather than the percentage. So all of these values would be entered as 0.975, 0.16, 0.475. And that's all that means. Numbers 4, 5, and 6, and 7 are kind of the same as well. They're giving you a value and asking you what percent of data is above, below, in between. So let's look at 4 and 5. They're normally distributed, mean pregnancy length with a standard deviation of 9 days. What percent would be expected to occur within 18 days of the mean pregnancy length? So they're not telling us the mean, but they're saying it's within 18 days of the mean, and the standard deviation is 9. If it's within 18, it could be plus 18 on top or minus 18. You don't know which. But either way, you get a 2, and it's either plus 2 or minus 2. And we know from the rule that 95% of the data is between a -2 and a +2. For number 5, oops, click the wrong thing on my document. For number 5, it's the exact same thing. The wording is the same, it's just the numbers have changed. 20 and 10 instead of 18 and 9. 20 over 10 is still 2, so this is going to be exactly 95% again. Okay, 6 and 7 are slightly different because they say what percentage of births would be expected to occur more than 20 days after the mean pregnancy length. So after, more than 20 days after. So that means we know the top is a 20. So we don't know the mean, but we know that it's 20 more than the mean. So the top is 20. The standard deviation is 10, so we get 2. Back to the picture. So a value of 20 is over here with a z-score of 2. There's 2.5% of the data above it. For number 7, it's almost the same, except the value works out to a z-score of 1. And for a z-score of 1, you have 16% of the data above that z-score. All right, and so that's how you do all these problems. You take the value and you find the z-score. Once you know the z-score, you just work with the percentages on this picture. Now, you can memorize the 16s and the 2.5s and everything if you want, or you can just remember this, and then when you need to, you can figure out, okay, well, if 68% is in the middle, that means there has to be 16 on either side. If 95% is in the middle, there has to be 2.5 on either side. But any way you want to look at it, once you identify the z-score, you can determine the percentage from that z-score to any other point. From here left, from here right, from here to another z-score. You could do from a z-score of -1 to a z-score of +2. It's just a matter of adding up these different percentages.